Meeting minimum ground clearance is a relatively common problem unique to site geometry, especially when abutment setbacks need to exceed 3 meters for various reasons, usually due to obstructions or erosion and slope stability. The EIA Bridge Binder Volume 2 for design, in Section 2.3, Geometric Requirements, requests a minimum cable clearance of 1.0 meters using the dead load or design sag geometry. And the learning objectives for this section are to first understand how to evaluate if the minimum cable clearance requirement is met and where to find this information. And two, actually measure that cable clearance for a suspended bridge in AutoCAD. Now first, what is ground clearance and how we're defining it? This is the distance between the walkway cable and the ground at any point along the bridge deck, which I've labeled here in the diagram. We want to ensure that the cables are not touching the ground or stretching to the ground at any point, as this would cause wear and tear on the cables, more erosion, and problems with the decking, as well as general serviceability concerns. You don't want to be walking along a bridge that is bouncing along the ground as you walk. Because of this, it is important to aim for a minimum 1 meter clearance under design sag. You can expect about half a meter drop in clearance from your design sag to the fully loaded condition. So this gives a sufficient factor of safety. Do note that the drop in the cable close to the abutments will not be equal to the drop in the cable at the low point. And also, this drop will depend on delta H of the structure. So in order to measure cable clearance, we first want to draw out the two limiting cable conditions in AutoCAD, using the main span geometry equations from Section 4.1 of the EIA Bridge Binder Volume 2 for design. I recommend using the arc command between the walkway saddles and the low point of the cable to draw out the cable. And from here, you can measure the cable clearance along the ground slope at critical points for both the design sag, which should be greater than 1.0 meters at all points, and the live load sag, which should be greater than half a meter at all points. So just to repeat that, we want to draw our main span geometry using the delta H, the sag for our design sag, and the tower saddle points using the arc command. We'll then measure our cable clearance along the slope. We can do this by inspection, just at critical points. And then we'll repeat this for our live load geometry, and we can figure out if we're going to have any problems with cable clearance and if excavation is necessary.